Hello everyone. So I will be talking about 2.1 polynomial multiplicity and end behavior of this new chapter. Okay, so this was originally a lesson from Friday, just that I accidentally forgot to upload it. Okay, so let me go ahead and record it. So when I talk about end behavior, guys, I mean these as x approaches positive infinity, as x approaches negative infinity, right? That sounds a bit confusing, but what I chose to do is to break it down. So as x, right, as our x values, right, this is our x-axis. As our x goes to infinity, so as x goes to the right, what is y doing? What is y doing? So for this specific function, we can go ahead and see that as x goes to the right, we can see that our function is going up, 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 and we can say that x, right, that y is also going towards positive infinity. Another way to say this is f of x is also going to positive infinity. Okay, another way to write this is as the following. As x approaches, right, this will be the approach symbol, negative infinity. So as x goes to negative infinity, so hopefully you are aware that that is going towards the left, right, because these are all negative numbers, and eventually we'll have negative infinity. Okay, so as x goes to the left, what is my y doing? So my y's of this function are going down, 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 down. So they are also going to negative infinity. So this is actually the cubic function. So we can go ahead and see that this is the end behavior. And as we go through the lesson, we'll start incorporating limits, and that will be a nice foundation for our calculus that we'll be learning. Okay, looking ahead, well, this was on Friday, so this won't be pertaining to us since it already passed. So let's go ahead and see the following over here. So the objective for today is going to be to sketch polynomial functions. First of all, what are polynomials? Use limit notation to describe their end behavior. So what we pretty much did, and their multiplicities. Okay, so go ahead and pause the video, write down this definition, and we'll go ahead and see what a polynomial function is. So hopefully you've actually seen these in Algebra 2. So polynomial functions is in this form. So it has exponents right here, exponents that are positive integers, meaning whole numbers that are positive, like 1, 2, 3, and so forth. So these are not square roots. These are not rational functions. And a must be a real number, so pretty much a positive or negative number. So for example, x squared, x cubed, stuff like that are polynomials. Okay. Oops. So for our visual learners, we can go ahead and see that polynomial is pretty much a graph that you go ahead and get it on your pencil and you draw something without picking it up, something continuous without overlapping, of course, will be a polynomial. This is not something that has holes, sharp turns, or discontinuities. Okay, so something like this, if I go ahead and draw it sharply, with sharp turns, this is not a polynomial, and if it has holes, definitely not. Okay. So something very important about polynomials, so you can go ahead and pause this so you can go ahead and see, so you can write down these notes. Polynomials have a degree. Okay, and that is the largest exponent, pretty much dictates overall how it will look like. And we can tie it down to parent functions, whether it is a cubic or an quadratic. So what I want you to know, degree is the number that is the largest exponent. So remember, here is x to the 0. So I don't write anything, I leave it as 1. So it's x to the 0, x to the first, and it's x to the 5th. So hopefully you can see that the largest exponent, our degree is 5. And our leading coefficient is the number associated with this degree, right? So this 3, our leading coefficient will be the 3. Okay, so overall it's not that bad. I want you to go ahead and see, first of all, are they polynomials, and then what are the degrees and what is the leading coefficient. So go ahead and pause the video, give it a try, and we will do it right now. Okay. So welcome back. So we can go ahead and see that in this f of x, we can see all of this is a polynomial because all the exponents are positive whole numbers. And we can see that our largest exponent is 3. So our degree is 3. And our leading coefficient, I'm going to say LC, our leading coefficient is the number, the constant right here, the number, the coefficient with that term. So that is 2. So easy peasy. For r of x, we do the same thing. Our degree is our largest exponent. In this case is 2. Keep in mind this exponent is 0. So here our degree is 2. And our leading coefficient, I'll call it LC, is 4. So far so good. Hopefully I didn't trick you guys with the next one. And keep in mind, the degree is a positive whole number, right? So this right here would disqualify all of this from it being a polynomial. So this is not a polynomial function. So therefore, this one, we don't have to find the degree, we don't have to find the leading coefficient because this is no longer a polynomial. Awesome. Okay, oops. So let's go ahead and talk about end behavior. Okay, so if the degree is even, if you have an x and the degree is even, that means that the end behavior are both going to point the same direction. Assuming it is a positive quadratic, they'll both point up. And if it's a negative quadratic, then it will point down. So pretty much this would represent something that is x to the second because it's pointing up. It could be the same thing as x to the fourth, x to the sixth, pretty much any even number, x to the 1000, if you will. Anything that is even will probably be pointing towards positive infinities on my y's. Now, something that I want to go ahead and stamp is that if it was a negative x squared looks like so. So they're both pointing the same direction, but now the y's are both going to reach negative infinity because instead of it being like a happy face up, now it's a happy face down, right? Okay, so let's go ahead and state the end behavior. So this is for anything that is a positive quadratic, right? So as x approaches positive infinity, that's what that should have been. As x approaches positive infinity, right? As x goes to positive infinity, what are the y's doing? So as x goes to the right, what is my y doing? Well, we can see that's going up, so that is positive infinity. The next one, as x goes to negative infinity, that means as it's going to the left. As x is going to the left, we can see my y's are going all the way up, and that's positive infinity. Okay, so these are both going the same direction. So they both rise, right? Alrighty, how about in an odd function? We can see that that is something that has an x to an odd degree, right? The parent function itself would behave like this, and that is going to be x to the third, pretty much something like that. So let's go ahead and see that my right will go ahead and go up, and my left will go like this. So I like to tell my students like, hey, this is like a ballerina, right? It's like this, my right hand's up, my left hand's pointing down, and I'm pretty much a ballerina. So let's go ahead and see this right here. And this will work for any function that is x to the third, x to the 21, x to the, let's say 45, x to the 1001 will all have this general shape, this general and behavior. Okay, alrighty. So what I want you to know now is that we can still find the end behavior, and that will be this right here. This will be as x approaches positive infinity, right? As x goes to the right, the limit as x goes to the right, my function, my y's are going up, 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 up. So that didn't change much. So let's go ahead and try the next one. The limit as x goes to negative infinity, we can see that my function itself is going downhill all the way to negative infinity. Okay. Similarly, if this has, let's say, a negative x cubed, well, now instead of me being like this, my left hand down, my left hand is up, and instead of my right hand being up, it's going to be down. So it's going to be now flipped, right? reflected across the x-axis. So everything's still the same from your Algebra 2 knowledge. Nothing like that has changed. Okay. Alrighty, so here I got a meme for us using parent functions on the new Xbox X series, right? Just kidding. It appears to be an Xbox One, but we'll take it. All right, this right here, guys, is a cheat sheet that I use for the following polynomials. So we can see that this is x cubed. It looks like so, right? If it's x cubed, it looks like this. If it's x cubed, but it is a negative x cubed, you can see that it's flipped. Same thing goes, x squared positive, x squared with a negative. So go ahead and see that these are the little cheat sheet in case you ever forget what's going on. Something we didn't discuss yet is max turning points. Pretty much you get the degree of the function, and you can go ahead and subtract 1, and that will be able to let you see how many turning points it has. And max zeros, we can see that the max zeros is the quantity of the degree. All right, so go ahead and give this one a try. Which would be a possible function for 4x cubed? So go ahead and pause the video, try it out. Okay, alrighty, so 4x cubed. So me, I'm gonna go ahead and see, first of all, is this a polynomial? So we can see the x cubed, so it is a polynomial. And this right here, the degree is 3. So it's gonna behave like x cubed. So which one of these looks like my x cubed? So hopefully you're able to see that this right here is my answer. And this is an x squared, and this is a negative x squared. So not that one. Okay, go ahead and try this one. 7x squared. Which one looks like so? So go ahead and pause the video, give it a shot. And hopefully you're able to see that since the degree is 2, right? The degree, the exponent, the largest exponent is 2, it's going to behave like a quadratic. Okay, so these are not to scale, but hopefully they still give you a general idea. Go ahead and pause the video and try this one. That's negative 3x squared. So this is a quadratic pointing down, right? Quadratic looks like this, but if it is negative, it's now downhill. It's a sad face parabola, right? Okay, so I encourage you to give this homework a try. The way it works is if you go ahead and look at the largest exponents, in this case, be very careful, I wrote it over here. So my degree is 3. Leading coefficient, that will be the coefficient in the term, so this will be a 1. The max turns is your degree minus 1, so that would be 3 minus 1, which is 2, and your zeros is the same amount as that. So be very careful because some of them will be negative. Okay, alrighty. So for the exit ticket, go ahead and go to the link and give it your best shot. See if you can match the functions to their associated graph, right? They're all sketches, so give it your best shot. Okay, now we'll complete our the characteristics of polynomials. So hopefully that helps. And I'll see you in the next one. Thank you.